So how are
Hey,
you doing today,
hi.
Manish?
I'm doing good. How are you?
Fine Saturday
Hi.
afternoon for you?
Yeah, not much different from the other days, but yeah, dealing with this pandemic somehow.
Oh yeah, all of us are. It gets a little, it gets really taxing sometimes, doesn't it? But
Yeah.
hey, we're going to be there for each other, of course. That's how it is. Anyway, so as a short introduction, Manish is a recurring speaker here with us on our events, and he is an engineer at Geo, and he's the engineering manager, and he loves to do design. He's been working with Geo for over 6 years now, and he's built endless stuff with them and on his own. Uh, well, his philosophy is that he deeply cares about the user and developer experience, and he has been working his way around these things for a long time. And of course, he's also a future tech hobbyist. So he's recently been dipping his toes in AR and VR, and your Oculus 2 system makes me very, very jealous. Just putting it out there.
Yeah.
Anyway, so Manish, I leave the stage to you, and okay, let's get this show rolling.
Great. I'll quickly share my screen for everyone. Is my screen visible? I hope it is. Let me know if my screen is not visible. Yeah. So hey everyone, thank you for joining us. First and foremost, I hope everyone of you are safe, and I mean you and your family are safe. Please do take measures so that you are away from COVID. Be inside, mask up. Foremost announcement. Yeah. So yeah, a little bit about me. Digvijay already introduced. So yeah, I'm Manish Kumar. I'm working with Geo for quite some time now. Been doing design whole my life and been doing front end engineering for quite a while also. Been working on web and mobile technologies, mostly React, Flutter. Been doing a lot of React, Angular also these days. Working on Geo's design system right now. It's pretty exciting. We are doing a lot of stuff around all of these platforms. Uh, uh, on my side, yeah, I deeply care about both user as well as developer experience equally because I truly believe you for us to build products that our users love, we'll have to uh, build tools and practices which are developer and designers love, right? So, and then like the which I mentioned, I'm also a future tech hobbyist. So I kind of you can find me playing with my Oculus, learning how to build apps and games for Oculus when I'm not working. So yeah, that's a little bit about me. Uh, so what are we going to talk today about is micro frontends. So just to make us all of us on the same page. What are micro frontends? Micro frontend is more of a blanket term for architectural pattern, where you kind of break out your monolith app into smaller pieces, mostly for scalability, efficiency of your teams, and mostly management purposes. So, I mean, in the example here, you can have a website or a kind of a web app where you have, let's say, a header, something of a sidebar, main content, and then these things are being plugged or powered with some sort of a style guide or design system component library of yours, and there can be separate data fetching logic also, right? And in a uh, in a large enough app, a complex app, you might want to have separate teams working on this, separate teams owning different pieces of your application. So yeah. So what does micro frontend basically promise? It basically promises a couple these things, which is independent deployment, independent development. You as a team, a smaller team, can take your own architectural decisions. You don't have to be worried about the whole app's architecture decision. Like if you and your team are more comfortable with Angular for whatever reason, then you can go ahead and build with Angular. You can take choices of what state management, how you want to do navigation. All of those things can be your choices rather than being bounded by the main app, the umbrella app, right? So that's what it supports. And then the final one, which is quite important, I believe, which is owning the technology as well, right? This is, I mean, if like I mentioned, right, if you are comfortable with Angular or React or let's say Vue or any other new technology, maybe Svelte, anything that you're comfortable with, you can choose that for now, and that works for you. And this system will support, or this architectural pattern will support for that. But this system also acknowledges that the inevitability uh, of that technology may be dying down the line, right? So tomorrow, what happens if React is not there? If Angular is not used by anyone anymore, it gets deprecated. Google comes up with a different framework. So what do? Do you go with your legacy app and start converting from scratch? So I mean, in different other technology patterns, it's not acknowledged that much. It's basically somehow kind of forgetting that this is there. But with Micro Frontends, it's right up front, and it promises that if you are adopting a Micro Frontend architecture, you have the ability of switching out any of the technology that you might be using. So that's cool, I think. So just to outline my thoughts, right? It's mostly a scalability problem, mostly a team scalability problem rather than a technology problem that is being solved by Micro Frontends. It's not like something can be done in React or something can be done cannot be done in, let's say, Angular or Vue, right? It's not a technology problem. It's mostly a team scalability problem. So uh, just a bottom line that this might be more beneficial for larger distributed teams who want to own their own experience of, let's say, a particular thing in your app, like let's say search, particularly if you want to have a separate search team who takes care of end-to-end search problem for you from front end to back end. That's when you might want to look into a Micro Frontend. So yeah, it's not that hammer, or it's not one size fits all solution. So don't take it that way. But what's the actual problem? Let's look at the actual problem with the today's setup. Why can't we distribute, let's say, if you're working in React or Angular or Vue, why can't we ask multiple teams to work together on one particular web app, right? So there are these general challenges of how do you share your code between multiple teams. Like if they're dependent on you to build, let's say, a button or let's say a particular feature, then the teams are not independent, right? They cannot individually or independently deploy their stuff. They are dependent on you to first build, and then they will be able to deploy their stuff in production, right? So code sharing has been traditionally been really hard, right? We have come up with multiple solutions, from creating libraries using npm. I mean, there are multiple things that you can do, but still code sharing is still hard. Other one is obviously the team scalability that I was talking about. And then consistency at scale. If you have multiple teams working on a particular large website, you might have seen examples of this out for a particularly large uh, organization, even for Google, Apple, you might see that it's not really consistent throughout the website. Uh, and I mean, it is only because there are multiple teams working on different parts of the website, different experiences of the website. So consistency at scale becomes a larger challenge. And again, this goes back to the same concern of code sharing, right? So how do you share code? So yeah, and obviously this also affects your developer velocity, because if there are multiple teams interdependent on each other, how do you make sure that everyone is up to date using the exact same version that you're using? So a lot goes around developer velocity as well. And then obviously there's vendor code sharing. So if you and your team are using React 17 because some shiny stuff, but some other team is still on React 16 and they're not even using hooks, let's say, then if you merge both of them, if you stitch at the final place, then there will be problems, right? So how do you share vendor code like React or Angular or Vue in the same stitched app or shell app, right? And then obviously version conflicts. So how do you avoid these kind of versioning conflicts when you have, like, if you have divided your website into 50 separate micro frontends, you'd not want all of them to be always on latest version or the version that you are using, right? Because of multiple reasons, every team might be on a different version of React, I mean, you might have to find a solution around that. So that's another general challenge around this, right? So what are the erstwhile solution around this? I'd not say really solutions. These are basically workarounds of creating or breaking a big monolith app into smaller chunks. So you definitely need stitching a base or some sort of a shell app where you bring the whole experience together, where let's say your search experience, your product experience, your help experience, login experience, all of that comes together as a single app for your user. So you still need to do extra work to manually stitch all of this. And there's a lot of manual work. And whenever there's manual work, there are chances that things might go wrong in production, right? And then obviously there's manual patching that although you build separately, but at the build time uh, or at the compile time, you kind of patch different modules together and try to make it as a single app. Again, affects the developer experience by a lot. Uh, uh, Third is frame-based composition. This is also quite popular in trying to achieve micro frontends, where you kind of divide all these separate boxes in your web app as iframes and then load separately different builds at runtime, right? But again, with that approach, there are problems. We'll discuss those problems separately. You might have also seen some examples of complete redirection. So you might be on a website, and if you need help, or let's say you need payments, you basically get completely redirected to a different website, right? It's a complete page refresh. It's not really a good user experience, right? So that's another way of achieving this, though, that two teams can kind of independently deploy, independently develop. And then there are current solutions from Webpack also, which is using DLL plugin, native ESM, externals. Externals is basically library. Native ESM and DLL plugin are some sort of promising, but it still doesn't solve all the problems that we're talking about. And yeah, what are the problems with these workarounds? The issues which you might have already noticed. This basically asks for bad user experience, right? There are situations where if you are having multiple iframes, you will see things loading at different times because of latency between those. You will not have smooth transitions because something is loading separately, something is loading at different places. And if you have complete page refreshes, that's definitely a no-no, right? Uh, I mean, it will obviously make it slow as well. Then there's a lot of manual orchestration for your shell app. So not really a good developer experience in this case as well. And then if you're doing any of these, the things that I talked about, there's a vendor code duplication, right? Like even if you go from one page to another page and there's a complete page refresh and you might have developed separately, the React gets downloaded again, the whole parsing gets done again. Everything is basically duplicated, not just the code. I mean, bundle size anyhow increases, but still, I mean, the only thing that you want to share is some logic between these two. And anyhow, you are using React or other dependencies, like let's say if you're using some sort of a state management, some sort of a navigation React router. So you can share all of those. There's no need for each page to download them separately, right? And then obviously dependency version conflict would be there. This will be really slow at development in any of the things that you do. And you'll unnecessarily induce bugs which are not, which you'd not even anticipate. And then, like I mentioned, you might have noticed this in large organizations, websites, government websites, that things are not consistent, right? And I mean, it baffles us that this seems to be a small website or small web app. Why is this not consistent? Because this is primarily because in large organizations, large corporates, you have multiple teams working on the same web app, but for different features, right? So that's what brings in the inconsistency. So yeah. What if I told you all of this can be solved with Webpack configuration? And if you're anything like me, you might want to run away right now. But hold on, I'd help you understand how this can be done in a slightly less painful way. I mean, I'm not complaining about Webpack as much, but I've found it difficult to deal with to understand the whole Webpack configuration. React CLI kind of abstracts all the uh, complexity of Webpack configuration away from you. But once you understand it's not that complex. So let's look at it. How can we solve for all the issues that we just talked about with Webpack configuration? So there's uh, shiny new feature in Webpack 5, which has recently been launched, which is called Module Federation. Uh, Module Federation enables you to have remote modules, exactly like local modules, with something called containers. We'll see what containers are in detail slightly along. So local modules are like normal modules, like which are part of your current build. So at the build time, Webpack knows that if you're referring to a button component, where is the button component? It builds a dependency tree and sees and does a lot of optimization also around that, right? If you have unused imports, it basically throws them out, creates a bundle which is optimized and efficient for you, right? But remote modules, Webpack really cannot do that with remote modules because it needs to know all of its dependencies, even for lazy loaded modules at the compile time, so that it can build the whole dependency graph. But with module federation, you can have remote modules that are not part of the current build and loaded from a so-called container at the runtime. We'll look at what container is, right? But how does it work? Uh, there are three small steps for any of your app which is being bundled with Webpack right now. And if it is using Webpack 5, you have to do three steps. One is you have to use something called module federated plugin in your Webpack configuration, which is on the left side. You can see module federated plugin. And then you have to define a remote endpoint, right? So I have defined here app2, at which is at this location, which is localhost 3002 with a remote entry.js, right? So this is the location of my remote app. And you can see in the remote app on the right side, I've defined that this is the name app2, that's the scope of it. And this is exposing something, right, which is a button, and it can expose anything basically. So it is exposing a button. So as soon as the remote app or this micro frontend goes live, this button is exposed, and anyone like app1 on the left hand side can consume it by just pointing to it through remotes, the way it is defined here, right? So how do you use it? As simple as an import statement with slightly separate pattern. And since these are async, you might want to load them lazily and maybe wrap it inside a suspense and with a fallback of whatever you want. So you basically have a React lazy with the import of app2 slash button, and then inside React suspense, you have this remote button, right? And we'll see example of this, of how this is working. But what about, I mean, okay, this solves for sharing the code at runtime. If something is live on different server, I can directly use that particular component from that particular server right in my application. This sounds too good to be true. But what happens when, let's say, I want to share uh, both the dependency of vendor code, right? Both the apps having same React, so I want to share React, or maybe I want to share React DOM. I want to share React router, right? So how do I do that with federated modules? It's again as easy as just adding a shared. This is slightly complex, not complex, advanced API of how you use shared. Ideally, you just maybe put shared with the array of strings saying React, React DOM, and you're done. And it will basically share React and React DOM between both of them. And you have to define this shared in both the shell app as well as the host app as well as the remote app. But in the advanced API, as I've shown here, you can ideally pin something to a particular version. So if, let's say, for whatever reason, you are dependent on 2.24 with semantic versioning supporting up to the patch version, you can actually do that also. So you can define a range of what moment is supported. And if you go into the advanced API, there are basically all the combinations that you can think of how you'd want to share between both the host as well as whatever is your remote. So yeah, sharing is as simple as that. You don't have to worry about any complex manual patching or removing things at build time. Sorry. Before we go into the demo, I'd want to talk slightly more in detail of how this works. So in the example scenario here, let's say this is your application where you have a home page and then you have a drop down which has the arrow icon. And you also have a login model, which is having a button, right? So if you see the tree chart here, homepage is having dropdown, which is dependent on arrow icon, and dropdown is obviously dependent on React. On the other side, login model is dependent on React, and login model is also dependent on a button because it needs a button for clicking, right? But look on the top right side where I've defined what is team A, team B. So assume that things were created or somehow structured in an organization like this for you to for different teams to take care of different components. So team B is basically only worried about its own components. It only worries about button, drop down, and arrow icon, which is dependent on React. So they don't really have to care about how login model would behave or how homepage would be, right? They just go and build button, they build drop down, they build arrow icon, which is only dependent on React. All they have to do is expose button and drop down, and they have to share React. They say that my React version has to be shared, my button is exposed, and my drop down is exposed. And as soon as they make that live, what will happen is there will be a container which will be created for this drop down. Uh, you can see there are multiple entries in the container for button separately, for drop down separately, and React separately. And all of this will can be referenced from a remote. Slightly deeper in this, how this works. So the external container is what Webpack will point to at runtime, which will have async dependencies on any of the components that you're creating. And at runtime, it will all be passed and would try to resolve at the runtime. So that's the key part here. It's all done at the runtime. You don't really have a compile time dependency on this. So yeah, a lot of talk. So let's go into demo of it, of how this actually works. I'll quickly try to exit from here. Yeah. And let's go to my, yeah, example. So if you see, I hope my VS Code is visible. Yeah, I'm sharing my entire screen. So if you see, there are multiple apps here. App one is basically my host app. It doesn't have much. If you see, this is just a shell app. I'll just run this. Okay, this is running. So this is my shell app, which is app one. And then I have a remote app, which I am wanting it to be a micro frontend, which is app two, which whose developers have created app two button, right? So I want to share this button from remote app into this particular app, which is 3000, which is running on 3001, which is a shell app, right? So how ideally would I would do this is, if I'll show you the app two also, so it's slightly clearer, and increase the font size if it's not visible. So yeah, in the app two, if you see, there's nothing. There's a button which is with certain style, right? So there's some button style, and there's this button, and this is exported. So if I need this, I would most probably have to create this as an npm package, install this inside my package JSON so that I can access it, right? A lot of friction plus a lot of delay, right? I mean, users will have to keep on updating whatever is latest on the npm. You will also need a different deployment as soon as the npm package gets updated. But as I mentioned, I just have to go in Webpack configuration. I have to expose my button, which is pointing to my button. I say /button, which is pointing to my src button. I save this. I go into, and in the other one, I have already done the configuration of this, where I say my remotes are my app two, which is running on 3002. So I'll just go in my app. I will import my app two from, I'll import my button from app2/button, and then just run it with a remote suspense fallback, right? And if I do this, I have saved this. If I come back, you see app2 button inside my app one. So what is happening if I go in my network tab and reload this again? Sorry, network tab. Yeah. And if I just look at the JS, so you might see there's something called remote entry.js, which is around 27 KB unzipped, but this is zipped would be around 3 KB or something, which is very minimal. It doesn't contain any code. This is mostly an interface of trying to understand what this remote provides. So that's what you get, you are downloading. Another thing you can see is there's something called srcbutton.js, right, which is only 2.21 KB. And this is getting live streamed from the other one. So if I stop 3002, it will fall back to loading button and it will not load anything. And I'll quickly update, let's say, button here. So let's say I change the color of this. And if I update this, obviously I'm expecting my button 2 to update, right? But what happens here? If I do this, if I refresh, I immediately get that. It downloads this again. This is again 2.21 KB, and I immediately get that. I don't have to deploy this on NPM and get this back. So this is a very simple setup that I'm showing you, where there's a host app which is sharing from a remote app, which is basically pointing to a remote app and getting this. You can extrapolate this example to understand. I was kind of building that for you, but I don't think I have enough time to show that. That you can basically import this from a design system, this button, and that design system is basically running off from, let's say, a storybook. So you can basically import all your components directly from where your, let's say, design system team is building it. They don't really need to deploy it separately, make a npm, and you don't have to worry about the versioning of it either. But what happens when you actually need a versioning of this? What happens that you're not ready yet to consume whatever has been updated in the app 2, right? There might be app 2 might have introduced a dependency which you are not using or you have not updated to. In that case, also there's provision where you can do version management in inside federated plugin, because the way this works is it creates those containers, right? Those external containers, and you can basically have different versions of the containers deployed that you can access. So yeah, I think this should give you a brief idea given the time frame. I think I can only explain this much. Digvijay, do I have enough time to maybe go slightly deeper into this? Or I can maybe take certain questions later. But yeah, I mean, this should basically give you slight more idea. Digvijay, if you have slight more time, I'd like to explain the React version pieces. I'd maybe take 2 minutes.
Oh yeah, absolutely. Go ahead.
Cool. So what happens, like I mentioned, how do you do vendor version conflicts, right? So let's go in app 2. Yeah, I'm in app 2. If you see, my app 2 is dependent on React 16.14, but my app 1 is basically on 16.3, right? Which, if you remember, doesn't support hooks, right? So what happens when I have a new version of a button, which is, let's say, using use state, right? So I have this new version of a button which is using use state. I'd also style this so this looks slightly better. Yeah. So if I do this, what will happen is my app 2 is working, where if you see, if I press, my hook is updating and I'm able to do this. But as soon as I try to do it here, it still is working. So how am I able to get a React version which was supporting hooks into a host app which is not supporting hooks? It did not download React separately, right? If you see, I mean, you can see it here. I'll redeploy this. It did not separately download the React piece. So how did it achieve this? So in the container, it basically tries to resolve and make your. So right now, I mean, I'll just go in the. So what I've done here is I've said, although I'm sharing React, but I want the React to be singleton. I'm sharing React DOM. I want the React DOM to be singleton, right? So if this were false, like I cannot really share the React version between these two, because let's say host is not yet ready for you to consume the latest version of React. What will happen is you'll not be anymore able to use this. Did I not save this? I did not. Yeah. Okay, I'll have to rebuild this. So you'll not be able to, because in this case, you're explicitly asking Federation to download the React with two separate versions, because obviously there's a setup in which you cannot use them together. So if you do that, you'll not be able to use this anymore. And if you go in console, you'll see that Webpack important module lazy is not really a function, because that is not really available, right? And if you see this app, remote app is still working because this is still dependent on that. So, and you can go into the documentation of this. There's really advanced API for which versions or how you can strategize what gets shared and what you might have to duplicate if you want to provide a consistent experience to your user. So yeah, it takes a lot of pain away. And like I mentioned, if you extrapolate the use cases, uh, user is only downloading the things that they need. They are not downloading a React version separately or React router separately. So the bundle size goes down by a lot, as well as if you want to use it or scale it even more, you can have a design system team working separately. You can have experience teams working separately, and they can keep on deploying their stuff. And you can decide which one to consume based on whatever your requirement is. And consuming, as I mentioned, is as easy as a normal import in your app. You are basically just doing an import of that particular button instead of doing from, let's say, npm library. So yeah, I think that is all I have from my end on this. If you have any questions, I think you will have to post that on comments, and I'll be happy to answer that for you. Thank you. Thank you everyone for joining.